from the top, between 11 to 13 inches. Mixture of clay and soil.
You'll be speechless when you first blow its core and how beautiful it looks. It's not just picking up a clay or sand, but when you actually dig down and see a core sample, it's nice.
That's Jonathan Rickard of Moose Cree First Nation, one of the peat core technicians who supported scientists as they mapped the carbon stored beneath our feet here in Northern Ontario.
Stay with us to learn more about this carbon measurement project that takes us from the muskeg to a convenience store freezer to satellites in space.
First transition of peat, soil, and clay, a mixture.
Wawatay Mitsue, Jocelyn Cheechoo, Mushkegowuk, Muskegowuk, Nduchin, Thunder Bay, Dashigan. Hello, everyone. My name is Jocelyn Cheechoo. I'm from Moose Factory, Moose Cree First Nation, and I live and work in Thunder Bay. I work with WWF-Canada as their senior specialist for the Hudson and James Bay lowlands. And one of the projects I'm here to present and share with you today is the work that WWF-Canada has done in partnership with Mushkegowuk Council and McMaster University that measured and monitored carbon in these communities, territories, and homelands. I'm here today with my colleague, Clare Wark.
Hi, I'm Clare Wark, and I'm a specialist on WWF Canada's Science, Knowledge, and Innovation team. And for the last 3 years, I've been working on our carbon monitoring project in communities across Canada, including in the Mushkegowuk region. And since starting this work, we've gotten a lot of common questions come up time and time again about carbon measurement and what it is and why it matters for those who live in these really carbon-rich areas.
So today we're going to do our best to share some of those questions and answers, such as what is carbon measurement? How does it affect the land? Who's involved? And why does it matter to not just those living in the lowlands, but to everyone?
We'll answer those questions with help from the people directly involved in the project, like Jonathan, who you heard earlier. Next up is Vicki Sahanatien.
I'm the Knowledge and Research Manager at the Lands and Resources Department of Mushkegowuk Council.
Mushkegowuk Council is a tribal council that works with 7 Cree First Nations in northeastern Ontario. Why did Mushkegowuk Council decide to work with WWF Canada and McMaster University on measuring carbon in the land?
Yeah, well, we're a small organization and thus we have very few staff. So we don't have the expertise to do research on carbon. So it's always a great thing to be able to access scientific expertise from other organizations. And especially for this project in particular, both organizations brought not just people power, but also the funding to do the work. So that's always important when you're working in a great large area like Mushkegowuk territory.
Could you tell us a bit about the peatlands?
Yeah, well, the peatlands, they're very large, of course, the second largest peatlands area in the world. I guess for us here in Mushkegowuk, the peatlands cover a great deal of our territory. I'd say 80% probably altogether. And these peatlands are diverse. They're very saturated with water. So very important in terms of productivity and supporting all of the biodiversity that also supports the nations that have lived on the lands and the waters, really, I guess, since time immemorial. And it's extremely important storehouse of carbon. And that just increases the value in many ways to the greater world, but also to the people that live here as well.
Vicki is referring to the Cree First Nations who call this region home, who live and learn in, work on, and care for the lowlands. Though these communities may be spread out across a large area, together they exercise their inherent rights and responsibilities to take care of the land. They sit at the center of a long history and future of a people and their homelands.
Since 2021, WWF-Canada has been working with Mushkegowuk Council and McMaster University on presenting community trainings with community members and research on carbon measurement. You may have seen or chatted with us during one of our visits in the fall of 2023 or the winter of 2024 when we traveled to Peawanuck, Kasashawan, Attawapiskat, and Moose Cree. We did try to get to Fort Albany, but there was a big snowstorm that closed the winter roads, and unfortunately we weren't able to get there. It's been almost a year, I think, since we went up to start reporting and sharing the results and what we found. I know we did go up during the winter road season as well. And I remember it was just so touch and go in terms of the winter road being ready and safe to travel. And I think that was, for me, pretty eye-opening. I mean, the previous winter, I don't think I was at home. I was here in Thunder Bay and reading the social media posts, but to see it in person. And then I think it was the last day when we were at Attawapiskat and the road, I think, officially opened to like the big trucks. And just seeing all the trucks coming up when we were heading back to Moose Factory. And it was going to get warm that day. And I just remember thinking, this is something else. Seeing like the mud and the grass coming out and everything really melting in front of our eyes. I remember that day so clearly and just thinking, I hope we get back. I hope we don't get stuck. It was pretty, I've never been in that situation before where you could see just from the forecast, it's going to get warm, but how fast things melted and changed in a matter of hours.
Although part of me was kind of reminiscent because of when we were driving and you could see those little peat patches poking through. It was like, oh, there's the muskeg. I didn't think I'd be seeing you because there's supposed to be ice there, but
let's get a sample.
Yeah, let's get a sample. Why not? Ice road sampling.
Sampling the peatlands. That's what this project is all about. Jonathan Rickard, who we heard from earlier, took part in the training provided by WWF back in 2021, along with community members from 5 First Nations in the region. Here he is again to explain the peat core sampling process.
My name is Jonathan Rickard. I'm from Moose Factory, Ontario, Moose Cree First Nation. In the past, I was environmental technician and aquatic technician. And for this program that I was in, it was a peat core technician.
So for some folks who might be listening who have no idea what is involved in taking carbon samples from the peatlands, can you kind of describe what you were actually doing? I know some people think it's just going out and digging up dirt.
When you go out there as a peat core technician, there's a special way of doing it. The tools that they have is very unique. It's something that I had to learn and take training on. And it's almost like a blade. So when you pull it out, you'll see different kinds of layers. And it's not the same way as pulling out a soil sample or a water sample. This core sample has different layers. And these layers have a unique texture to them. They've been there for like hundreds of years. So those kind of things are very interesting, like when you actually look at them. So being a part of that, it was beautiful. Being part of that team and understanding the core sample and how to extract it and how to bag it and how to tag it means everything in terms of being a core technician. So my experience of that was very educational because that was my first time doing it when I was working with the WWF.
Is having the opportunity to work on the land important to you?
Yes, it is very important. And the reason why it's very important is because people don't get to see the things that people should be aware of, like in terms of decrease in population of water life. But when you do the work, it's something that we feel like we all should know. And I feel that other people, not just like my generation, but people younger, should be getting into this kind of thing as well, because they're the ones that's going to be taking over this kind of data later on, and they're going to be reviewing it later on. So I feel that's very important.
Over the course of 2 months, local teams did sampling across 4 watersheds, covering difficult terrain and pulling a total of 27 cores along the way.
Each sample leaves behind a small hole about the size of a golf ball that will naturally fill in over time. It's important that the process disturb as little of the ecosystem as possible. which is why all the sampling is done by hand instead of with big machines.
Technicians record the exact location and details of each core sample, and then the cores are carefully packaged before being sent to the lab.
And that's where the team in the field sometimes needed to get creative.
When we were doing the coring along the Moose River, we had all of these cores at the end of our trip. We needed to store them somewhere, and so we walked down to one of the convenience stores. We knew they had a freezer because they had all these frozen desserts, and we asked them if we could store these cores in the freezer. And they were like, okay, what are you talking about? So then we had to give the whole spiel on what we're doing. We're going out coring. It's just dirt, it's not scary. It's just regular dirt. We showed them some of the cores that we had in our truck. They were like, okay, this is kind of weird, but if you come back tomorrow, we'll clear out a freezer for you and you can put the cores in the freezer. So we showed up the next day with all these cores. They even helped us move them from the truck into the freezer, which was really great. And I don't think that you could really do field work anywhere else in Ontario and have that experience where you walk up to a convenience store and ask them to store samples in their freezer. And they're like, yeah, I guess so. And so in terms of the number of samples for that one community, it was enough to fit in a freezer, and there was still room on top for some mixed food items.
From the ice cream freezer, the samples travel south to the team at McMaster University.
I'm Cheryl Rogers, and I'm an assistant professor at Toronto Metropolitan University. But the work we're going to be talking about, I participated in as a postdoctoral fellow at McMaster University.
Would you be able to tell us a bit more about McMaster's role in the carbon measurement work that took place in the Hudson and James Bay lowlands?
Yeah, for sure. This was all planned collaboratively involving the Mushkegowuk Council and WWF-Canada. So at all stages, everyone participated in the planning and participated in the measurements on the ground. So traveling to these areas and actually collecting samples. So it was a really collaborative role, which was really, really nice to participate in.
So what are some of the steps to measuring carbon once it's in the lab, once the sample's there? What happens?
Yeah, so once we're in the lab, we take that sample, we segment it into chunks, we dry those chunks, and then we figure out how much carbon is in each chunk of that sample. In order to measure carbon content, the way that they did it was through burning the sample. So you burn the sample off and then weigh it again to determine how much carbon is left after ignition. Organic material burns quite readily. So if you heat this sample up to a specific temperature, that carbon burns away, and the difference between the original weight and what's left tells you how much carbon was in that sample. The Hudson and James Bay lowlands are a particularly important area because the ground stores so much carbon. So this area is filled with wetlands where vegetation and organic material decomposes really, really, really slowly. And so all of that carbon that vegetation takes up over time ends up locked away relatively permanently in these slowly decomposing landscapes. So we have a rich storage of carbon in this important landscape. In order to understand exactly how much is stored, that involves sampling the shallowest peats and the deepest peats so that we can get a better sense of how we might be able to detect this depth and this carbon storage using satellite data that can fill in the gaps between on-the-ground measurements.
Satellite data. This is the part of the project that takes us up into space.
That data, which is gathered through remote sensing, maps out a lot of detail in the lowlands: temperature, type of vegetation, elevation, and much more.
But satellites can't see below the surface, which is where those chunks of muskeg come in. And so does another McMaster researcher.
Hello, my name is Yiao Li. I'm a fifth-year student in McMaster University. I major in the Earth and Environmental Science with focus on remote sensing. I have 2 years research experience in McMaster Remote Sensing Lab, and I have started to lead my own research project, Hudson Bay peat depth mapping.
Yiao and her team have built a super detailed map to show how deep the peat is at any given point in the lowlands, and provide an estimate of how much carbon is stored there too.
To get this map, they put peat depth measurement data, geospatial information, and satellite data into machine learning models. These models are trained on data to predict how deep the peat is across the entire lowlands. But to double-check that the predictions are accurate, they also need data from the field so that the computer can make better predictions in the future.
These field data have played a very important role in validation step of my research. The peat depth data we use to train the model. So this field work provides the essential independent validation data for us to evaluate our model performance. By comparing the field data with the model's predictions, we were able to assess how accurately the model reflected the real-world conditions.
Okay, we've got our super detailed map of how much peat and therefore carbon is in the lowlands. But what's it all for?
Why go to the effort of sending people out into the field, collecting the samples, freezing them, drying them, burning them, and then combining them with data beamed down from space? Here's Cheryl again.
This adds information to help manage these areas. So we know that carbon storage is important. We know that the release of carbon to the atmosphere is impacting climate change. And we know that these communities that live in these areas are disproportionately vulnerable to changes in climate and changes to their way of life. The field data is really the key that allows us to do that. The more field data there is available, the better these models will be. So more field data is always better, but we can't sample everywhere. We can't take the entire Hudson Bay lowlands back to the lab. So it's a really important piece to be able to conduct that fieldwork on the ground and link it to what we can see from satellite data. We know that this is a really important landscape. We know that this area stores an extremely incredible amount of carbon in the ground. We also know that as climate is changing, that carbon that's stored is going to be vulnerable to being released. And that can be through permafrost loss. It can be through wildfires. Any of these types of disruptive events can release carbon back into the atmosphere from this type of landscape. So a lot of focus from a research perspective is looking at understanding the variability of carbon in these landscapes and understanding the vulnerability of that carbon to various disruptions. So this work really links to the work on understanding the importance and the vulnerability of the landscape. And it also gives us an understanding of the spatial variability of carbon across that area. So understanding the vulnerability of the landscape and where that landscape is most important to mitigating climate change is really important for managing these landscapes and protecting them as well.
At the end of the day, all the science is about protecting the land and empowering the people who live on it.
And that involves sharing what we've learned, answering questions, and addressing concerns in communities.
Claire, what do you think about sharing some of your visiting the communities, presenting to the schools? Everybody always wants to know, what did people say? How did it go? You know, especially people from home.
I think something that was evident from those community gatherings was really the interconnectedness. And I find this is something that oftentimes, like when you're talking to academics or researchers, they get so laser focused in on their specialty, their like carbon and like their end goal of publishing a paper, that they kind of forget that there's this really complex interconnected web. And then when you go up to communities, they don't just have questions about carbon. They have questions about, okay, well, how does this impact the moose? How does this impact the muskeg and the river and water quality? And so there's all these different questions that come up that if you were so laser focused on your project and your paper and your carbon, you would kind of miss out on it. This isn't just about carbon, which might not be that interesting. It's about everything. It's all interconnected.
Yeah. Being born and raised in Moose Factory and spending time up on the James Bay coast. I used to go spring hunting there when I was growing up and into high school. How special and unique that whole region is. It's not until you go up there and you see it, like how vast it is, how the birds, the water, the rivers. Like it's so impressive, and it's not until you see it, you see the scale of it. And then when you go into communities and you see their canoes and their boats, you see their ATVs, you see their trailers to transport their boats to the rivers, like you still see that people are still going there, going to the land, going to their camps, going fishing, and it's really, we can talk about how carbon rich that area is, that region, but it's still such an integral part of the Cree communities up there. And that's something I think that we need to always remember and keep in the forefront, that these communities will be there for a long time. They've been living there and existing there, and it's their home, right? And that'll continue. I think that needs to be said as well for this region.
I would really say that the role of WWF Canada at this point is to be listeners, like to really just listen to what community members are saying. Like when we're sharing the results, we're going to be doing a lot of talking, but we're going to hold space and have time for community members to respond and to take time and ask questions. And so I think our role at this point is really to listen and not just, let their comments and questions kind of fall on deaf ears, but actually take that into consideration for what we do next.
Mm-hmm. I think, too, another thing that we seen when we were there in October, and I've noticed this for the last few years when I've been home in Moose Factory on the Moose River, is how low the water levels are. Like you could almost walk across. I didn't think it was just unique to Moose River, but when we went up north and we saw the Attawapiskat River, we saw the Albany River, we saw the Winnisk, it was devastating to see how low it was. And then that was around the hunt break time too. Schools closed for hunt break in October, cultural break, and families go fishing and hunting, and people start moose hunting. And we had gone to schools after that break. I remember going to some of the presentations and speaking to some of the students, introducing myself, telling them where I'm from, telling them I grew up hunting and camping and fishing with my mom, my dad, our cousins, extended family, and asking them, so how was your hunt break? And some of them said we couldn't go because we couldn't go by boat. The water too low. So it's seeing and hearing that, the youth, you see that, the young people see that, and it's changing how as Cree people have lived on the rivers and lands for as long as they've known. It's starting to change, and the young people are seeing that and experiencing that.
But this partnership between WWF, McMaster University, and Mushkegowuk Council has the potential to help decision makers tread more lightly on the land. Here again is Vicki Sahanatien of Mushkegowuk Council.
The peatlands are diverse and they're heterogeneous, and you can see that from the air. You see that texture. It's not just one big giant bog or swamp or fen or something like that. It's quite diverse. And that's important. So we need to recognize it's just not one uniform place. So we need to treat different parts of it differently, perhaps. And here I'm thinking of maybe potential development down the road and that kind of thing. And I guess for Mushkegowuk Council, but I think also for the nations, when we're looking at future development in these peatlands, we have to look at, I guess, socioeconomic cost, potential cost. So it is very useful for us to have better and better estimations of what the carbon stocks are out there to help put into processes like the regional assessment for the Ring of Fire or developing the road up towards the Ring of Fire. And that's a factor that should be taken into account, that any of the construction is going to disturb a certain amount of carbon, and therefore how are we going to kind of manage that and take that into account and the cumulative effects of development, and especially for certain areas that are being targeted for development right at this time.
Like everything related to climate change, carbon mapping is done with an eye to the future, and especially towards those who will steward the land long after we're gone.
I was just thinking about some younger audience members tuning in today to our show here. I was wondering if you had any advice for them who are interested in anything along this type of work.
Yeah, absolutely. If you're interested in contributing to solving environmental challenges, there's lots of skills that are related. So we had people participating in this work that were helpful in navigating the terrain and making sure that we were safe out there in the field. We had people involved who had local information, local knowledge, and that was all invaluable. We had scientific knowledge on the team. We had people that were great at coordinating this massive effort. And so all of these different skill sets contribute to making that field research successful. And all of it was absolutely necessary as well. And so there's a lot of different ways that you can contribute to solving environmental challenges. And you don't necessarily need to do that from the scientific angle. You don't need to do that from the fieldwork angle. Whatever your interests are and what you like to learn or do in school, think about how you might be able to build those skills in a way that contributes to the challenges that are of interest to you.
Here again is Jonathan Rickard.
My advice, I'd say, if it's out there, when there's a project that's going on, environmental programs, I invite youth to be on part of the expedition to see how the work's done. So those opportunities will help to see what's going on, to be very informed on what's happening to our land, see who's involved, and see what's happening to the negative impacts as well. And maybe the younger generation can help eliminate some of those negatives that's happening to our lands. So my advice is if it's out there, go out there and see it, be a part of it.
Measuring the carbon in the land and protecting it is a massive undertaking. Like the soil itself, it has many layers. It involves traditional knowledge holders, scientists, technicians, and communities all working together.
Carbon measurement could be included in community-led environmental monitoring and guardian programs, which support efforts to steward the land. It would also likely add new data to support the Mushkegowuk Council's conservation priorities in a region that is under a lot of pressure from developers and government.
For WWF-Canada, I'm Clare Wark.
And I'm Jocelyn Cheechoo, Miigwech. Thank you for joining us.